recorded.
Need to find. Okay, so normally you should see it. Okay. So the last time we actually configured some lab. In my case, this machine, virtual machine, didn't really restart. So in RTP, so I can see my lab is still running. So should have it restart, I just need to restart it again. So I guess most of the people here, they probably still have their lab running from last time. I see some router running here, so it should be okay. So to remember you actually need to telnet to one of this to this address here. That's the current machine. Like I said, when I see the network, I will move it to a known name and then I will communicate that to you. But right now, I just SSH to this address with my user ID. And if you don't remember the password, I set it to Cisco 123, unless you already changed it. This machine is, as I said, just to run the lab. And once you have the lab, you can actually access like you would eventually access into a Calo, except that you access a virtual router. So this is what I'm going to do here. I will start again all my connections. And if you remember, actually, all the information is in my lab TCL. So if I do this, if I didn't remember, I can see them using those router. I see that I have my tunnel running, so that's okay. And I see that all my routers are still running fine. So I had 4 routers because I didn't want to actually configure one for service. One was a CPE, one was a LAC, and then this 62 was the AG. So normally, if nothing changed, I should still be able to connect. And for those that have downloaded this, they can use this one. Again, didn't have the time to change the script, so I've corrected the script already. There were some issue there, but I didn't download to this machine yet. So let's go to start this machine. So if I look at the IP address that I have in ifconfig, this is the main address. And if you look also, you can see the different tunnels of the people running the lab. So for the moment, I guess there's only like 3 labs started. So, eventually, if you're a bit lazy, you could potentially copy this config later on. You might just need to change some network stuff and your radius. So you have your radius config here. So you could adapt this one. And eventually, the redirection that we will do later, you will need to adapt also. But for the rest, it's going to be more or less the same config everywhere. So anyway, there will be a training here. That one here, I will leave it on. So if nobody damaged the config, you should be able to even go back to this one. So, and the password is Cisco 123 for this username also for the moment. So let's start this lab again. I mean, actually, let's go to the console. Okay, so we'll remove this Linux stuff for the moment. We don't really need it. This one I will remove also. So for the moment, I have 4 routers. One is not really required because we will start with doing PPPoE and doing the VPD and stuff. So for this one, I will move it down. So for those, I don't know, you have seen VPDN already? Oh. So VPDN is a protocol to transport the PVP to a remote site. So if you have the PPPoE discussing here, you can actually move it across IP between those two. So this is what we want to do actually. If you want, I can still do the presentation for VPDN if you are not really familiar with it. It takes about 15 minutes, I guess. I don't know if you're interested. So we'll remove this CDP because it's pushing the message all the time. So I guess nobody's interested in the training. So we will start with PVPoE. And we know that we had some connection of directly here. I will try to find my lab again that I had before. Where did I put it? I had it one somewhere. Maybe here. No. Just to go through the drawing. I think I lost it. So I will actually do the net map. That should be giving me some output. So I went through the Linux and I have this net map here so I can still recognize really easily without having a drawing the connectivity. So I have 100, Ethernet 00 is actually going to 161, so 161 is the one here on the bottom. We could create a PVPoE there. What we also want maybe to start with is maybe create a PVPoE directly to the SG, and that's going to be this connection here. So if I configure this, I will first take those two routers, and then after we'll go a bit more complicated in doing that VPDN. So we know that interface Ethernet 01 is actually connecting to each other. Show run interface Ethernet 01. There's nothing configured. So I actually need to start a PVPoE session. So what is a PVPoE session? It's just a PVP that is going over Ethernet. There is an RC for it, and if you look in the RC, you will see actually a very easy protocol, which is 4 packets. You first initiate, you get an offer, then you request, and you get the session. So that's just to kind of open a PVPoE tunnel between both routers. And what is a PVPoE tunnel? It's just a header that is sent together with the PVP packet, and the header contains the PVPoE session. So not very complicated protocol if you would look at this RC. So, but maybe to actually enable it, it's a bit more complicated. So let's move this LAC somewhere there, and I'm going to send this PVPoE over here. So first, when you configure PVPoE, you actually need to configure a BBA group. You will see some old configuration referring a virtual template directly. That's a very old one, so don't use that one. Use the BBA group. You have many routers, especially like ISR 4421 and so on, that actually can initiate a PVPoE client. You also have the possibility to do it in an ASR1K. If you would want to do a lap with a back-to-back ASR1K, you can actually initiate PVPoE session also from ASR1K. But here, often, that will be the DSL router at the customer, the one called CPE here, and this is the one that will be configured for. So you will see few Cisco iOS router also doing this functionality. So what I will configure here is a VRF. So when I actually configure this PVPoE dialer interface, I will move it to VRF so that I can create multiple CPE in the same router here. If not, so I will get confused with the routing and all that stuff in the global. So we'll configure this with the VRF. So let's take the new one, VRF definition, and we're going to call it CPE direct, for example, because it goes direct to the or PPPoE direct, maybe. So this is the PPPoE that will go directly. If you look at those new definition in VRF, previously we were using IP VRF, then you have to configure a route distinguisher. But here you don't even need it, does it automatically, unless you start redistributing in the VRF, but here we don't. Just find IPv4, and that's it. It's already done here. So for the VRF we have found, and we're gonna go in configuring a PPPoE client. So as if the customer was actually configuring his 800 or ISR series. For this we need the interface, and we know it's an Ethernet 01. So for example, I could also configure on the Ethernet 01 in this IOL a .1Q. So later, maybe if we want to assign another one, or if you take this training and you actually create a new user, you could do this, and or because you have a customer that is using that specific use, you could eventually even set it here in this static setup. So interface Ethernet 01, we're gonna call it 100, for example. 100. There's a slash too much. And obviously here I need to configure the encapsulation.1Q, and to stay logical I will put 100, but it's not a requirement. Then VRF forwarding, we actually at this point I will get the PPPoE packet, so I don't really need to configure any VRF. There's no routing in this one. You will see if you look at configuration of a customer configuring this in a small CPE, you will see PPPoE and then enable and some group. When you do PPPoE client, you don't really need this. So if you have PPPoE, you see that you have a possibility to configure PPPoE client, and then you actually need to configure a dialer pool member. There's a lot of people having confusion about dialer pool member when you start looking at the access side. So this is like, you could imagine that you rent a car at budget, and budget says you can take from parking 1 and parking 2, and then you leave from those parking to wherever you have to go. So here it's a bit the same. A dialer interface will be able to use something to go out, and it's coming back from the time we actually had the dialer access. Obviously this code has been used for PPPoE client, but eventually you select something to go out. And with this dialer pool member, you actually configure the parking of the budget car rental. So when I give a number, for example, 1. I can go from 1 to 255. With iOS and iOS XC, if a customer has multiple PPPoE clients in the same CPE, he cannot use the same number here, because it would end up in the same dialer, and you don't want that. It's a dialer per PPPoE client. So here, if I do a show one of that interface, yeah. What did I miss? Strange. Show one. Maybe it's because it's on one of those pigeon images. I don't know. So here, if I look at my config, you can see they actually enabled this. So you will see a lot of people retyping this. I've seen ones doing a problem. Actually, when you do PPPoE client, you just need this one. He does this one by default. So as I say, this is the place where we'll open the tunnel to the ISG, and now we still need to configure everything that is IP or even PVP, because PVPoE is actually PVP over Ethernet, but we haven't seen anything from PVP yet in that config. So what's the next part? We're going to configure interface dialer. Again, the number can be selected. It doesn't need to be the same as the dialer pool number 1 here, but just to stay logical, we'll use this one. So how do you you are in the office of budget and they tell you the budget to rent a car and they tell you to go and select from the parking, or in this interface you can actually say which one you're going to select to go out, knowing that this is actually dialer pool number 1. You just need to configure dialer pool 1. So there is some, if you look at some people doing dialer, they will ask you a question about this stuff here, like which one? Dialer string. You don't need for PVPoE because you don't need to dial. You have dialer models, enable timeout, all those stuff you don't really need. So for this, we don't have much to do on the dialer functionality for PVPoE. As long as we map this interface to wherever it needs to go out, which is in this case via this PVPoE client, it's enough. Over the dialer interface, they can support multiple encapsulation, so we need to start with encapsulation also, PVP. And then there's nothing else on the back. Yeah, but you can see that you can actually configure some other stuff, even X25. So if we start a PVP session, and that's going to be the case for most of the CPE that is connecting to a service provider that is here, the ISG, we're going to need to send a password. There's a lot of confusion when they configure this, and maybe one day you will face this because some guy is doing it in the lab. You see this PVP, you can do authentication, and then you would see PAP or CHAP or whatever. So since the guy say we're going to authenticate with PAP here, the default that the engineer will do is actually configure PVP authentication here, also PAP, which is not needed. The command here will actually tell this router to try to authenticate the remote one, but you don't do this with the ISP. In the service provider environment, it's only the ISP that will authenticate it to you. So you can just suppress this line, and you will see there are people doing dial in because obviously when you dial in from there, you did do the authentication, and when you dial out, you don't. So you will see those type of config, but just remove the command, you don't need. The only thing you need to be prepared is actually to be able to authenticate. If the service provider tells you who are you through the PVP negotiation, is gonna have to give you're gonna have to give an answer. So let's do this with PAP. So the command PVP PAP send username, and then you can start sending a username. And I will, for example, put a username. Oh, sorry, something moving. I will put a PVPoE direct. Why not? At cp.com, for example, so I can potentially do some stuff with the domain after. Password, Cisco, for example. Don't put a space because it's actually taking the space as part of the password. You're going to have a lot of trouble. So if I do a show run of this interface, you can see that I will support PVP, and I will do a show run of interface 0/1.100. If it works this time, it doesn't like do. So if I look at this, I'm gonna start an encapsulation PVP where I'm gonna start it to something that is able to send it out. Previously, in the old time, it was an ISDN, or it was this modem connection or whatever. Right now, we're just gonna send it into this PVPoE client, and the PVPoE client will be triggered to talk to this service provider. Obviously now I'm still missing something, and it's the layer 3 protocol. I haven't configured it yet. In the case of this CPE, and in the case of most of the service provider, they will actually negotiate the IP address. So you will see IP address negotiated in most of the case at the CPE side. So this is one way to configure. You could do PPPoE client test and generate PPPoE client. With this one, it's nice because every time your router comes up, it will try to bring this session up. And actually, sign my interface is up. It should probably already do some debug. If I debug PPPoE packet, probably I will see sometimes some packet going out because everything is actually ready to do it. If I do no shut of the dialer, it will probably go a bit faster. So hopefully it starts, because otherwise we might have another trouble. Okay, so you see here, the first PPPoE packet is a PADI. We'll see a bit later, maybe if I debug some other stuff, it would actually tell me that it sends a PADI event. I can do this, probably. It's going to give me some information. You see a broadcast address, so it's trying to find anybody. So this kind of packet needs to go on the broadcast network. And here is its source address. And then you will see some protocol, of course, here, 8863. 8863 is the one I use when he's trying to negotiate the tunnel, the PPPoE session. You can see that changing in 64 when there is data. So even though the PVP might not be up, PVP is part of the data for this session, so you will see 64 changing here. And then some type of header and so on. So that's how you're going to establish the PVP. And you can see here, he's sending the first packet, which is PADI. He's trying to negotiate that session. Obviously, on the other side, I haven't done anything, so nobody's answering. What is also a problem is that if you do this in the lab and you have some router configure for PVPoE server side, it will accept this packet and will try to actually enable the session. Maybe he succeeds because it was actually configured for. So you're going to look at your CPE and at the ISG, but you will never see a session here, or you'll see a session there. So interesting then is actually to look at which MAC address is replying to you, and you find out that is actually not your ISG. So now we need to configure the other side to accept this PVP, and this is what you will see in ISG side here. The first thing you need to configure when you want to accept a PVPoE is a BBA group. Yeah, I don't know if some of you did BNG before on iOS XR. You don't need to in iOS XR as long as you do enable PVPoE protocol on the interface. It will work. While here you actually need it. So BBA group is a group that will terminate the PPPoE session. And you can see that you actually right now have only one option. You can see keep the keyword global, or I can put whatever name I want. For example, PPPoE SG, for example. So here you can see that there is a virtual access coming up directly, is because when we enable the protocol PVPoE inside our BBA group inside that iOS XE, it will create a base interface. So if I do show run interface virtual access 1, there's nothing yet really configured because actually there will be a base interface. But if I look at the show interface, probably with the T, you should see that it's actually base. So you see, create the base. What is it used for? When we get new connection, we will create virtual access 1.1, 1.2, and so on, until all the sessions are up. But this one will be the base, and we will keep it. You might have sometimes virtual access 4, 5, and so on if the guy is doing PPP modeling. Then it's a very rare case, actually. I think it's only BT that was doing PPP modeling with this iOS XE. So what is a virtual access? it's an interface that we will use for PVPoE. And it has a big advantage that since you have an interface, you can do cost on it, you can do per user cost, you can create an access list on it. Every subscriber PVP will have a specific interface, whether they come directly from that PVPoE side or if they come from a VPN, we have a specific interface. There's a drawback with IPoE, so if you do DHCP, you don't have an interface like this per user, which means if you do cost and all that stuff in AZ, you probably need a service. But we'll see the service later on. So here I have enabled the BBA group, but I haven't done anything. So under the BBA group, you can do some limits. For example, if I look at the limit, you can do PADO. You can limit offer to some service name. So in this packet that you send here, you could send some tag in PVPoE, it's all tag, and you could select for specific service. So you could eventually configure this on this PVPoE session, so you can spread subscriber that would have been fit with that configuration. Most of the time, I don't see much people playing with this. You can do the session. You can session per VC, by default 100. So you will see maybe if you ever enable an ISG, and maybe the case will go from aggregation to you because you cannot enable more than 100 sessions. So they will say it's ISG, so it's your fault. But actually, by default, you have a limit of 100 per VLAN. So if you see this limit not lifted and you see a round number of sessions that the customer complains, it's probably that. So you can change it here, for example, to 1. So per VLAN, you can do per MAC. That's interesting in a lab, for example, if you say generate session from the same MAC. Could be. It's possible, and it's allowed to have PVPoE session from the same MAC coming in the box. Most of the time, the customer will limit this also with the authentication part of it. So you will see a user might only have one session in this box. So when you try a second one, they will reject the session. So then eventually this limit per MAC and so on is not really needed. But anyway, the most important stuff in that BBA group is actually, again, as opposed to here we were sending PVP into PVPoE, here we need to take from PVPoE to something. Since we subject to have tons of interface here, we're not going to use dialer, because if you would use dialer to terminate this, it's going to be a pain. You would have a 20,000 interface maybe if you have a small router to configure, which is obviously not what you want to do. That's why the concept of the virtual template. Virtual template is a template, as you say. Some customer think it's a real interface, but it's not. It's always down. So if he's using this to route, it's a pain because he doesn't understand. This is just really a template. What it is used for is to take the config of that template and create a virtual access with it. The virtual access is a real interface. Unfortunately, you cannot really route with virtual access either because it's changing all the time. So the number would be messing up routing. So we can select virtual template 1. I think you have 255 or so here, maybe more depending the version or less, like here in IOL. So let's take 1 to make it easy. So once I have the associate, or I need to eventually send this PVP from that BBA group, I can configure my virtual template. Obviously, now I have configured this BBA group, but I didn't attach to any interface. So this is what I'm going to do here. I'm going to enable this configuration. So if I look at show run, I didn't do much so far. I guess it's BBA group somewhere. And you see here, I'm associating just a virtual template. I haven't configured the virtual template yet, but I can eventually already assign the PVPoE protocol here. Like another interface or any other protocol, if you want to support the protocol, you actually need to tell the interface that you're going to support it. So if you want IP, you configure IP address. if you want PVPoE, you just configure PVPoE enable. Dash enable, like we saw before, but now you can actually define your group. And since we specify a specific group called PVPoE ISG, this is the one we're going to assign it here. So once I type enter, this interface will be able to accept PVPoE packets, which probably you will see this one start negotiating already because I have the virtual temp, the BBA group configure. So let's see, just before I go on in configuring the PVPoE, if he's actually doing something, which I think it is a bit strange. So probably this packet is maybe not sent correctly. I don't know. Right now, if I would look at this interface, it should. Okay, I know why. It's because I configure this under .1Q100, and here I didn't configure the one. So show run interface Ethernet 0/1. You see here, there's no .1Q, so it didn't react. But I can remove it there and create a 100 like the other side. No. If you have any question, just stop me. So now I'm assigning this under this sub-interface. So, and I can see there's a bit of movement here on the other side. We can see actually the protocol PVPoE here. I send initiation, which is a PADI, and I can see the broadcast. So hopefully somebody picked it up. Now I can see the PADO, the offer coming back from the other side. And if I look here at show interface, Ethernet 0/1, or see this MAC address, 8210, and I can see it correctly here. So it's really this one responding to this packet. And it's an offer because there is a O. Then we should see since I offer this guy something, he will probably need to request it, which is with the R here, but R, and you can see, I guess, if we would debug this with the sniffer trace, you would see a bit more in details. Here, the reply from the server when we actually send a request from the CPE is to say, you have a session. So far, it's nice. But we know here there's no PVP configuration, so it shouldn't last for very long. And actually, this is what's happening because right after we see an outgoing PAT-T, which is probably PVPoE failing or something like this. So PVP failing, sorry. If I debug PVP negotiation, maybe I might even be able to see something on PVP. Let's see what he does when eventually he sends. With this diary, you will send it from time to time, and we would see something at PVPoE first, and then PVP that starts sending packet over it. So here we see a PVPoE session starting again, and directly after, we actually have a notepad directly. Don't know why. So maybe there is some issue here, because I think it should start PVP in this case. Anyway, let's see if I configure the other side if we go a bit further. Or maybe the incoming PAT-S is a bit confused for him, and he just sent, with this I cannot do anything, so he's just clearing up. Maybe, again, a sniffer trace would actually tell something. Anyway, here I was having the PVPoE configure, so let's see what's happening here. I need to configure virtual template so I can terminate PVP. Okay. Interface, virtual template. One, obviously the number needs to match. This guy I would eventually need to terminate PVP. By default, he will do. So the virtual template is always PVP. And then there's no need to configure encapsulation PVP. Obviously, in PVP, I want to authenticate in this time because I really want to authenticate this other guy. And now you see that assigning the virtual template without anything is enabling PVP packet on the other side, and we see already the PVP negotiation. And the problem is that obviously when you reach the protocol of IP, I haven't configured anything, so the problem we can see here didn't really negotiate an authentication. So let's start with that, PVP PAP, PVP authentication PAP. So normally now it will eventually ask the other side to do PAP authentication, which we can probably see here if it did. Okay. So if you don't know PVP, this is what's happening. On PVP, each site can configure themselves. And there is a lot of confusion because I saw a case with some engineer and the customer opened it, and even the DE is a bit confused on it because it doesn't reply the correct stuff. So you can see here MRRU, which means is the MTU. An MTU can be configured differently in both directions because each session each site is actually telling what he wants. If the other side accepts it for whatever reason, even though he eventually was configured to do less, you might just have to MRU different in both sides, which means here we see an incoming configuration request. It's an ISG, an ISR1K will always react like that. When he sees it's a PPPoE, he enforces 1492 for MTU, which is expected because it's the RSV. So it tells the CPE, if you want to send me something, send it at 4 times 1492. This is actually what it tells here. If the CPE does not agree, maybe it will say, no, I don't want 1492. It will enforce something. If the CPE is okay with it, it means that we should, from the ISG, not send more than 1492. If the CPE, like in this case, send a node configuration request, we would eventually agree with it, so that means we can send him 1500. So PVP, always look at both sides. And so just to go back to that protocol, we have a configuration request coming in. We should reply with a conf ACK, a conf reject, or conf NAC. And if I look at this, I need to look at out, so it's a reply. Is he actually matching a conf NAC, conf reject, or conf ACK? Here in this case, we have a conf NAC. So here, this CPE will enforce, so we can eventually change that behavior by doing MTU 1492. Let's see here. What do we see? It's an ID 1, so this ID also needs to match. So a request needs to be replied with the same ID. Some question on magic numbers. You can see here that we're actually using a magic number. Here there's already a mistake because there's no magic number replied here. And normally it should eventually take back that magic number. Here we see a config ACK with nothing. So it seems that there is no feature. Where is it coming from? It must be an outgoing configuration request from this one because it's incoming. So somewhere I should see the outgoing configuration request, which is here, the ID match. The ID match. So again, you see the both way of this communication. This one didn't request anything. So the CPE sent a magic number, and we can see that the config ACK is referring that magic number, which is okay. Normally, if you would see an outgoing configuration with the magic number, and assuming this ISG would send an out configuration request with the exact same number, then this CPE will detect a loop. but here it's correctly handled. So doesn't ask anything. It means it's actually an MRU of 1500. So if you don't refer it, it's actually okay. So actually, at the time we are here with these two packets, we have configured our site, or I would say the CPE site, with 1500. So each side is actually already finished for LCP. And you can see here, LCP is the first phase of PVP. So we still need to look at the other side. And the other side started here, asking an MTU of 1492, asking the CPE to use an authentication protocol PAP. And for some reason, the CPE didn't really agree with this, and he says, I don't like your MRU 1492, I actually want an MTU of 1500. Is it allow? Yeah, we support it on the ISG. So eventually, we see that the ISG resend an incoming configuration request with this time an MTU of 1500, but it still wants the CPE to authenticate with PAP. So you see this packet here, and only at this point when the CPE send that configuration act, it's actually okay for the ISG LCP part. So with this, you can see that you can negotiate a lot of stuff, even not even talking about IP or authentication right now. We can change MTU, we can change call back in the time that we were doing Microsoft PCs. We can change multi-link, everything in this negotiation. But always look at two sides. Both sides needs to be complete. If they're not complete, they will never reach this state open for LCP. If you're missing config in one direction, it means something is wrong with LCP. We'll never get to the open situation. So that's PVP. You will see something similar later on with the NCP protocol, which is the one we negotiate for IPv4. You see here the second phase of PVP is actually to do the authentication, and in this case it actually fails. Might be normal. So what do we do for IP address on this virtual template? Because again, each site, when they reach the protocol to negotiate to send something across, could have been IPX, could have been AppleTalk, but obviously with internet, we're going to go for IP. So here we need to support a protocol, and let's see, IPv4 is probably the next that we want. So most of the time, the customer will do a number and configure loopback. And that's actually, this is the way to configure it. Because if you really put a network under the virtual template, you will be stuck with about 10 of 5 interfaces, depending the releases. Why? Because it's going to create an interface every time, a virtual access interface with a network and not a number. Which means that at some point, the iOS will say it's enough of those, and you will create like 10 interfaces. That's it. So like 2 or 3 times over this type of stuff. Especially the customer will test in a lab with one user, so it's always working very fine because it doesn't exceed the number of interfaces. And then you deploy in production, and then you find out they can only have 10 CP, and then it's P1. So here, let's see, put also the back one maybe. So this is a common mistake. It's actually configuring IP number loopback 1, but not configuring the IP because they forgot. So even though you see a message reminding you, it's not going to change. They will probably forget. So but I will do it on purpose so that we can verify after. If you want to authenticate somebody, like any type of authentication, you need to configure a username and a password somewhere. You can configure it in the radius, or you can configure it locally here in the iOS. iOS has the possibility to authenticate. Since iOS actually already configure AA in this case. You know, remember when we did the copy show run? We have this AA commands somewhere. here. We have auto authentication for login. Obviously here is not a login, it's a PPP connection. So we need to look at this AA, again, that's how you start. We know it's an authentication that we're gonna handle, and we know it's actually the protocol PPP. So we're gonna configure this here. Authentication. And then I can select, obviously, whatever I want to authenticate. And you see some of old protocol like this one, but we are not really interested in there. We want to look for PPP. PPP, that's what we're going to authenticate. Default, I could give a list name, but for the moment I'm not really interested. Default, what do I do? Local. I could do none, and then I would not negotiate this. I will do a local, and here I could eventually still use some other methods going to the radius. If you do radius first, he's going to try the radius. If you ever reject, he's not going to go anywhere else. If you do local, he search if he has the information locally, and then he go to the next one if it's not present. Here we have local. So that means when I get an authentication for PPP, I will look at the local method. So far, I didn't configure username password yet, so I need to still configure this. And obviously, since it's local, it's really easy. Just username. Username. If I look at my config here, the dial one, I was using PPPoE direct password Cisco. So let's put it here. I will remove the 0. And make sure you really don't have a space, otherwise you're going to have trouble again. That should probably give him the opportunity to going through the authentication. We can see it here. We can see that we go into phase authentication. We send an auto authentication request, because why we suddenly would eventually send this is because through here, the AIG enforce the authentication for this PPP connection. Next step, obviously, you want to send an IP packet, and you can see actually here which username is sent, so potentially you could debug here and find it in the debug. Here you can see he's sending another configuration request for IPCP, which is IPv4. So he wants to establish an IPv4 connection, or at least a protocol between both peers. And since he doesn't know his address, he will put 000. It's actually normal. Then you see this incoming configuration request 000. This is because I didn't configure an address on the loopback, which means this one says, but no, I don't really agree with 000. You reject that config. And here also we have an incoming configuration reject, so both sides don't like 000. It's a bit of a problem for the central side, because potentially we know that the CPE doesn't know his address, so we will need to give him one. It's obviously not the purpose that the CPE would give an address to the central site. So that we need to configure. So for example, I could configure under the interface loopback one IP address 168.1.1.1, and this one I will actually put a /32. That would give him a way to tell the other side whenever he wants to send something to me, he needs to use his address. Would he agree with it? It's another question. We can probably look again at this IPCP. We see an incoming configuration request, so something coming from the central side. And that central side, which is OSG right now, is telling that CPE my address is 172.168.1.1. Does he agree with it? Again, for incoming configuration request, we need to look at config, confnat, confreject, and the same ID, which is here ID3 config. So he seems to agree with that IP. For that matter, we have been okay setting up IP or IP from ISG side. And we know that when he's going to send a packet, he's going to send it to this. Or at least use this one as a default gateway. The other problem is obviously that we need to give an address to this guy, and we can see that it probably starts with 00, but we still didn't really agree. We have a configuration request reject. So you see here trying to discuss his IP address, but the ISG didn't really reply with something correct because he rejected it. Or can we associate an IP address to a user? There are different methods again. We can do it from radius by sending framed IP address attribute. We can do it locally by assigning a pool. I'm not in an interface virtual template, so I need to go back to this interface virtual template. Peer default IP address. And then you have a few options. We can associate from a local pool. That's probably what you see the most. You can associate from DHCP, not something really you want to do because that will be creating a client function for this subscriber, and you actually request a DHCP server. So it's a lot more extensive for the ISG. You can also create a DHCP pool, which means you have a DHCP pool somewhere configured in the ISG, and maybe you're using some relay or some other stuff. So kind of referring to a local DHCP pool configuration here. So this one, don't use it that much. I think there's one customer that did it, and he actually really create like a proxy, I would say, of a DHCP client. So when your PVP session comes up, it's like you proxy, like if you bring up your PC, it's doing exactly the same. So it's a lot of work for the ISG, so maybe not something you should recommend. So here, pool, obviously, it's the most easiest one. We'll take that one first, and I need to give him a name, so let's call it PPPOX. So now that I have assigned that pool, I need to eventually go and configure the pool IP local pool. And then obviously I need to put the same name. And in this case, I will give him a range of IP address. He doesn't need too much. This one can be even public addresses here, because since this will be a /32 and a /32 route will be installed in the CPE, we can have something completely different. For example, here, don't give it this address or this presentation to, or maybe I will put a real network of 10. So 10, I could use that network, 1.1.1 to 10.1.1.20, for example. This is my local pool. So let's see what he does. Actually here, you see that something is completely stuck. If I would do show users, you will see this PPVE. This is something typical that you might also see if the guy installed it for the first time. He didn't notice that one side didn't really configure the IP correctly, because potentially he agreed with what the ISG side used, but we never agree on something, an IP address for the CPE. This is what you see in this negotiation here. But still the session is up. So customer will try to ping, but ping with what? If you actually look, there were no negotiation. And that will be eventually the first time he actually try, and he says I ping, but it never works, and obviously he didn't notice the mistake on the ISG side to bring up the IP address to the end user. He didn't configure any pool and stuff like this. He will try again, and if you ping, why not? Because it's actually here. it will obviously fail. Ping. There's not even a protocol running because TCP doesn't have any IP address, so let's try. Yes, also configuring interface loopback here just for the fun. Actually, I should probably put it in the VRF, this interface, but let's first try like that. IP address, for example, I could put one. There's a stuff in iOS when you don't have any IP up, it actually doesn't want to send something. So 1, 2. So we're just going to bring up some protocol here. So maybe I can try that ping now. You see, that's what he will see. He has the IP address, and he cannot ping. But just because one side didn't negotiate the IP address. Something you could see often, especially when they forget part of the config. Maybe, eventually, if your radius is not returning a framed IP address as it's supposed to return an IP address, you would actually see the same. Here, the only thing we need to do is actually clear the session. In the latest release, I don't know which version I'm actually running here. In the Polaris, we have show subscriber showing this. Maybe this one was already showing this. Show subscriber. Even though I'm not doing really ISG, you see that I have this show subscriber session command. So you see here, I have some information for PPP connection. Again, don't be confused if you see this. Maybe the box doesn't really run ISG, and it used that command to just show the PPP session. Sometimes to queue the case is a bit of a trouble. But here, if I do show user, I will probably not see any address related to this guy. And you can see, it's very clear here that something went wrong. But you will actually not maybe use this in the beginning, or customer will not see it. So when you look at the PPP connection, it's really easy to actually do show use on both sides and see if everything is installed correctly. So right now, it's not. And you can see here this virtual access that we created. There is some command for this, so interface virtual access 1.1, and then it's config or something. Configuration. With all those boxes doing all different stuff is a bit difficult. You can see how we actually configured this virtual access. So like I was saying, a virtual access is created from a virtual template. So we look at the configuration of the virtual template because it's a template. So run. Let's see what he did. Interface virtual template. Well, the virtual template has the IP number loopback, peer default, and PPP authentication. And we can see that he actually cloned it correctly from that template. What you might see later is new stuff here in this list. Whatever you get from the radius, you will also see here in this virtual access. Because when we clone a new interface for a subscriber, we obviously look at the template, but we also look at what the radius returned. And if we return interface loopback 5, although template is loopback 1, radius has priority. Always priority on the radius. That's the rule. So you will see this changing, and that's how you can actually achieve a per user configuration, because radius can return whatever you want for it. And as long as the attribute is understood by ISG, you can clone this into this virtual access. Not only that, but you can also start giving information for ISG. You can do a lot of stuff from the part of the radius. But we'll do that obviously later on in some of the next session. So right now, I should be okay to actually do a PPPoE connection with this. Let's see here, I will clear the PPP. You can do clear PPPoE session. I think there is even a clear PPP session. You can clear all, you can clear an interface, you can clear PVPoE, even I think the MAC address, all, or you see the remote MAC. You can do a lot of stuff. So obviously here I have only one, so I will create a clear PVPoE session all. Why? Because I want to make sure that I can actually pick an address from this pool and that eventually I discuss an IP address both ways. So I already know I'm getting very far, and the only thing left was really this one. So I will clear this stuff. It's good because now we can compare. Let's see what's happening to understand a bit of this, what is here. So we have a configuration request here, and then we should see it coming in. Sometimes you will see, you know, the first packet is not fully set up yet. Don't worry. If he continues, it's fine. Maybe some customer will complain. Just try to calm him down. It's not really a problem. Especially in ISR9K, you will see that we kind of missed the few first packet. Anyway, here I see the outgoing configuration request, and I can actually see the same ID. Obviously, in an incoming configuration request, I should send an outgoing ACK. It's done here a bit later on. At the same time, I see this outgoing configuration request here, and we can see MTU 1492 again, enforced by ISG because it's PVPoE, and if you look at the RC of PVPoE, you will see why. So here we have 1492, that incoming configuration request, and we can see the negotiation both ways like we actually did before. Here we actually gonna force him to do PAP at this point. So we're waiting here for the incoming authentication request. Obviously on this side is an outgoing. If you would see an outgoing authentication request here, it means the CP is trying to authenticate the ISP, which is probably not something he should do because you will not reply to it, and obviously this connection will fail. The only thing in PAP, you will see an incoming authentication request. In case of CHAP, you will see a challenge coming in, or at least a challenge response. And you first will challenge, but then you will see the reply. Once the authentication succeeds, you should actually see this. So in between here, we have the LCP. But here you see the phase PVP is up. And we see also the authentication ACK. So seems okay. If you're doing VPDN behind, so you forwarding this session, it's possible that you see a failure to authenticate, even though you actually never reach the radius, because through the VPDN, the video cannot really install it. It will refer it as a failure to authenticate. The reason is that normally the last device should actually authenticate this user, which is called the LNS, and it didn't. So it's really authentication failure. Anyway, here we are fine because we see the authentication phase went fine after the LCP phase. So always three-phase PVP. Then we see this IPCP negotiating, which is good because we have IPv4 here only. If you would see V6, maybe IPv6 CP, where you negotiate IPv6. When a PVP session negotiates an IPv6, it just creates a local information, local link information. You still need to kind of get the IP address one, and most of the CPE also do a prefix delegation on the IPv6, so a bit more complicated than IPv4. So here, let's see what it does. We see an incoming configuration request, and we know it's actually the ISV telling his IP address. Does the CPE agree with it? Seems to. It just agree. At the same time, you see here at the beginning, the CPE wanted to put 000 because he doesn't know his address. So he says, well, the 000. We should see the same here. We see this incoming configuration request from that CPE. At that point, you see the authorization is actually taking care of this in the ISG or whatever aggregation you will select here at this point an address returned from the radius if it was provided through an access accept or a local pool. And you can see here he's looking at the local pool and he's actually picking up that one. Once he has this address, he tells the CPE, I do not agree with 00. I understand you want to do IPv4, but I do not agree with that value, which is specific of a conf NAC. If you see a conf reject, he actually say, I do not agree with this protocol or this stuff that you send me. So conf NAC is better because you understand he wants to do IPv6, but the value was incorrect. And normally from there, the CPE should come back and tell the ASG, here is my configuration request, and I'm actually picking up this address that you gave me previously in the conf/NAC, and I hope you will actually hack this one now. So let's see. We see this config/NAC arriving at the CPE, okay, and then you see the CPE reacting to it. I says, okay, if you didn't agree with the value 00, let's try the one you gave me, and this is 10.1.1.1. which we obviously going to see here, and then eventually the ISG should hack this one because it's actually the one he gave previously. What is the next step is obviously to install a route, and you will see this. If I do show IP route, you will see the /32. You see here, the /32 is installed to virtual access 1, which means if I ping the remote, which is obviously 10.1.1, you should always use this sub-interface here, virtual access 1.1, which is the interface I create automatically when the user was actually coming in. So should work. It's nice. Here also, show IP route. I should see the route to get to the ISG. And I can see it here. So this is my ISG address. Obviously, this is a bit troubling because now you need to route statically all the internet, which is a bit of a trouble. Maybe you don't really want this. Maybe you want this because you have segregate some network via the dialer, or maybe some customer use this also PPPU connection to maintain the CPE. So depending a bit on what they do. But right now, we're looking at some internet connection here for this one. So show VRF. I was using PVPoE direct. I will actually insert this in my interface dialer 1. Show run interface dialer 1. You can do a shut of this interface. Actually, if you want to remove it, you also need to shut it. So I will do a shut, and you should stop the connection. You can see here the PVP going down directly. So first, you see that outgoing path T at the PVPoE session, and as soon as this one will receive this ISV, it will drop the connection. Sometimes you see this path T coming from a CPE because the PVP negotiation caused him to actually drop the PVP session, and then he sends the path T. So I saw a guy once doing this. He told the customer, it's your CPE problem because it's actually not going path T, so it's the CPE terminating. But what he forgot is that over PVPoE, there is a PVP session, and it was the PVP session actually terminating first. Here you see that for some reason, even though I actually shut down the dialer, he's still trying some PVPoE. We shouldn't, but anyway. I don't think anybody will fix that bug. So what I wanted to do is actually first maybe moving this one to a logging console, logging console information. So we'll not get the debug anymore. Do show run interface dial 1. I want to put the VRF here. And if you're in the lab, it's actually interesting because potentially everybody could create his own user and test stuff. Even if you have a real machine, you have different possibilities. So with the new methods, it's VRF forwarding, and I forgot the VRF again, which was PPOE something here. So I will put this error in the VRF forwarding. And what I'm going to do additional is PVP IPCP, if I remember correctly, default, root default or something, which is going to be installing default route with the remote address I received from the ISV. So if ISV change the address in the loopback, it's still going to work. So we're always going to point to the remote one they actually negotiated, that the ISV negotiated as his own IP address. So let's go and unshut the dialer now. Again, I went through something, and actually here I see some problem. Incoming protocol reject. So I send the configuration request, which is my own IP address, but this time the remote is actually not agree with that. He actually reject the protocol, which means basically he doesn't support IPv4 anymore. And actually, when you configure VRF, you need to reconfigure IP address, which I didn't do. So it was a good example on or you can debug very easily. IP address negotiated. Voila. Should be now just clearing the VRE session and restarting once more. Don't do clear PPPoE all on the ISV. Here you see that he actually changed the address. It took the next one in the pool. As a point of view of negotiation, we have pretty much the same, except obviously that he's using now 10.1.1.2 instead of 10.1.1.1. But if I now do show IP route for this VRF, which was PPPoE something, here I can see a default route installed, pointing to the remote. So now every packet that I will send will actually get this as an XOP, which is actually my /32 that I received from the AG. Exactly what I want. It's interesting to do this. Why? Because sometimes in the service provider, they're using BRAS for PPPoE, but they kind of spread the PPPoE session across two boxes. So here in the middle, you have a broadcast domain. It's a VLAN, it's maybe something else, but basically you transport the Ethernet, and then you actually arrive at the other side with that Ethernet frame. The other side could have two ISV or two aggregation of PPPoE, and then it's going to present that packet that we first saw, the PADI. This one is going to present to both boxes in the central, which means the one that is fastest will reply first with the PADO. Maybe you will see two PADO of each box. The CPU will probably select the first one, and maybe it's not anymore this ISG, but it's the other ISG. Bad luck, because you were just debugging this one. So sometimes you need to be able to look at two boxes at the same time for PADO. But suppose this ISG here is configured with a loopback, like here 172.168.1.1. The other ISG is configured 172.168.1.2. If you start doing manually a route 00 to this one, which means static routing, once you move to the other ISG, it will fail because that one will not be seen anymore. So you will not see the default route. with this trick of show run interface dialer, you will see that it's actually changing it all, pointing the 00 to the address you received through the PVP negotiation. So this is a bit of PVP and PVP. So I don't know if there's some question for this. And obviously I can ping it through the VRF, which will be interesting when we do ASG actually. So going across that PVP connection. Interesting to save. So this is the PVPoE session. Not sure if we still have the time to go to VPDN or if we do this next time. Shanga, what do you think? I guess it's probably going to take another 30 minutes for an hour to bring up the VPDN, so maybe we do it next time.
Yeah, I think that would be a good idea. I think we're only 90 minutes, so we'll give back some time, you know, to our team. So, team, do you have any question for Alan? Yeah. So, yeah, I think we'll do the VPDN session in the next slot.
So here I'm copying, so if somebody's interested in getting back the config, I will update this config all the time. So if you go to your user in that machine, you can actually look at this. So far, I haven't done anything specific, so if you want to plug it into your lab, it would work. You know, you can select that file and copy it back. So next time VPDN, and then after we'll start with the ISG, configuring ISG.
Okay, great. Thanks, Alan. Thanks, everyone.